What's going on, guys? We're at the end of the road for the unit. We have one more task, task 6, okay? And I'm gonna go over two major ideas in this task. The first is how to find the limiting reactant in a given problem using stoichiometry, using random conversions. And the second is going through the process of, all right, going from the beginning, given grams of some reactant, right? Like we have 10 grams of each reactant. We have 10 grams of baking soda, 10 grams of vinegar. How do you figure out, how do we determine how much product we'll get from this type of scenario, okay? You have to go through limiting reactant first and then go even farther into the stoichiometry process. So I'm gonna go over those two topics. All right, let's watch a couple examples. Okay, let's check this out. First thing, quick review, quick launch. I want you to answer these questions. How many moles are in 35 grams of water and how many grams are in 35 moles of water? And I want you to think about when you do this, like it's 35 and 35. They're the same numbers, but one is grams, one is moles. And what the answer means in terms of the difference between grams and moles, okay? In other words, they're the same number, but they mean different things. And the answers will tell us that. Try doing this on your own first. This is kind of like a launch question, warm up. Before, obviously I'm gonna go over the answer, but try doing this first. Pause this video, try this first before you see how this is done, okay? See if you can do this from memory or just by looking at some of my old lectures. Okay, so if we're going from grams to moles, we're gonna go from grams to moles by dividing 35.0 by the molar mass of water. That would be using this formula that we can write down. So that is always given grams divided by the number of moles, okay? Divided by the molar mass, which we find on the periodic table, okay? So if you look at the periodic table, we would see that H has a molar mass of 1.01, okay? And O has a molar mass of 16. We add all those up. We add 2 H's and 1 O. So we would end up with 2 H's, 1 O, which would get us about 18.02 grams per mole. So that will be water's molar mass. That'll go in the bottom here. 18.02 grams per mole. Those grams cancel out, leaving us with moles as our final unit. And our answer is going to be moles of water. Let's contrast that with how to go from moles to grams. So think of it as the opposite, okay? The opposite of dividing grams and molar mass is multiplying grams and molar mass. So we're going to multiply our given grams times molar mass. So we'll do the same thing, except this time we're multiplying. I meant same numbers. So 35 moles times our molar mass, 18.02 grams per mole. So as we can see, the answer is going to be way bigger. So this is just to show that moles and grams, while they are related, they definitely are they mean totally different things. So the answer for this is going to be 630.7, which we could round to 631 grams of H2O. Okay? H2O.